Don't forget to like, subscribe and share the videos.
This bacteria. Like we have discussed in every environment session of ours, we'll be discussing the basic concepts, at least one basic concept of environment. Okay, for today we have aquatic ecosystem. So what is aquatic ecosystem? What are its classification? What are the features of it? All those details let us understand. First thing is aquatic ecosystem. What are the major abiotic components of aquatic ecosystem? So when there is an ecosystem, what is ecosystem in general? Ecosystem means interaction which is happening between an organism and another organism, and also between an organism and its environment. So ecosystems key word is interaction. Any ecosystem's key word is interaction. Interaction between what and what? First is organism and organism, and then organism and its environment. These two interactions are called as, the study about this interaction is called as ecology, and when it operates as a system, then it is called as ecosystem. So when it comes to aquatic ecosystem, there is going to be interaction between organisms and also its environment. So like sunlight, dissolved oxygen, water nutrients, these are the major abiotic components of aquatic ecosystem, which means it will be influencing the biodiversity in aquatic ecosystem. In terrestrial ecosystem, water as such becomes an abiotic factor. Okay, so in terrestrial ecosystem, water is also an important, availability of water is also an important abiotic component. But here the system that we are discussing here is aquatic ecosystem, where water is everywhere. Okay, everywhere it is water only, then only it is an aquatic ecosystem, be it ocean or pond or river, whatever it is. Okay, so let us get into furthermore details of it. Aquatic ecosystem is always three-dimensional. What are the three dimensions of aquatic ecosystem? First thing is dimension 1. What is it? It is latitude. What is latitude here? We all must have known this, right? Equator, poles 90 degree, 90 degree. North and south. Okay, so these are the latitudes, 30, 60. These horizontal lines are the latitudes. So what they are saying, with increase in sign of latitude, there will be decrease in biodiversity. So what is increasing in sign of latitude? When we move from equator to the poles, then that is called as increase in sign of latitude. Okay, so it can be either way, to the north pole or the south pole. Okay, so when we increase the sign of latitude, which means when we move from equator to the poles, there will be decrease in biodiversity. This is a thumb rule. That is because, like we discussed in the first slide, what are all the abiotic factors which is going to affect aquatic ecosystem? Sunlight, water nutrients, and then what else did we see? Sorry, dissolved oxygen. Yes, dissolved oxygen is another abiotic factor, right? So when there is going to be increase in the sign of latitude, then there will be decrease in sunlight's availability, there will be decrease in dissolved oxygen, and there will also be decrease in water nutrient availability. Okay, so because of this reason, there is decrease in biodiversity. The second dimension here is longitude. What is longitude? That is the vertical lines. So these are longitudes. Okay, so for example, when we consider India, this is Bay of Bengal, okay, and this is Indian Ocean. It is an open ocean, and this is Arabian Sea. Consider Bay of Bengal. Bay of Bengal is longitudinally, we can identify it. Okay, from this longitude to this longitude, from this longitude to this longitude, Bay of Bengal is present. Okay, so the second dimension here is longitude, and it is shoreline to shoreline. So from this shoreline to this shoreline, that is longitude. Okay, and what is the important point here? Margins, that is coastal areas, are more productive than open water. So Indian Ocean here is open water, but then this is marginal area. Okay, I mean it is near the coastal waters. Okay, coastal areas. Those regions are called as marginal water bodies. Okay, so those marginal water bodies will be more productive, which means biodiversity will be higher in those water bodies when compared to open water. Here the open water example here is Indian Ocean. Okay, this is because margins have dual nutrient availability. Okay, so there will be nutrient supply from the rivers from all direction here, and here nutrient availability will be more when it is compared to this region. So when there is higher nutrient availability, there will be higher biodiversity. So this is the second dimension that we are talking. Okay, so water nutrients, and then the nutrient from the neighboring land fed by rivers and sea waves. Okay, next, the next dimension is the depth. Okay, here biodiversity will decrease with increasing depth. Why? What is the reason? That is because of sunlight penetration. Okay, for primary production to happen, sunlight availability is very important. There are three types of lifestyles in an aquatic ecosystem. First is planktonic lifestyle. They are also called as drifters. What are drifters? That are not attached. Any organism or any plants that is not attached to the floor is called as drifters. Okay, so the best example here is phytoplankton, which is a primary producer for which sunlight is required. Next is nectonic. Nectonic means swimmers. All fishes will come under this category. Next is benthos. Benthos means attached. Attached means they are attached to the bottom of the floor. I mean, they are attached to the floor of the sea. They are attached to the bottom. They are attached to the floor. So when we consider like this, planktons will be here at the top. Here also you can find planktons, and everywhere you can find, okay, these are the fishes. These are the fishes. These are planktons. Okay, these are planktons. They are found here. And then benthos means it is attached. These are the three different kinds. Okay, so you have planktons, you have nectons or nectonic, and then benthos, which are attached. Okay, so this is how the organisms are classified in aquatic ecosystem. Furthermore, details here. Vertical habitats. There are two vertical habitats. Vertically, we can classify the habitat in aquatic ecosystem. First thing is photic zone, and the second one is aphotic zone. What is photic zone? Sunlit zone is called as photic zone. It is also called as limnetic zone. That is up to 1200 meters. Okay, 1200 meter. It is called as limnetic zone or photic zone, which means up to that depth sunlight can penetrate. And in this photic zone, it involves both production and respiration loss. Like we saw earlier, sunlight is very much required for primary production to happen. So beyond 12,000, 1200 meters, below 1200 meters, there won't be any sunlight present. So primary production cannot happen. So it involves both production and respiration loss. What is respiration loss? This term I have explained in greater detail in one of our previous session. So what is respiration loss in general? When there is going to be loss of energy when compared to higher trophic level. Okay, so from one trophic level to another trophic level, only 10% of the energy is transferred. Okay, this is called as 10% rule. I've discussed all this in that particular session. So there will be loss of energy when we move from one trophic level to another. Primary producers will be having the highest energy. When we go to tertiary consumers, then there will be lowest energy stored in them. Okay, so it involves both production and respirational loss, this photic zone. Okay, And throughout the photic zone, with increasing depth, primary production decreases. Yes, there will be higher primary production at the top because sunlight availability here is more. When we go deeper and deeper, sunlight penetration becomes lesser and lesser. That is the reason there is decrease in production, and respirational loss is also going to increase with increase in depth. Next is production becomes zero at this particular depth, that is 1200 meters, but respirational loss keeps increasing even beyond that depth. Okay. So next is aphotic zone. Aphotic zone means darker zone. I'll explain this in the picture in the next slide. Okay. So what is aphotic zone? It is dark zone. It is also called as profundal zone. This is limnatic zone and this is profundal zone, and it is up to 4000 meter. Here 4000 meter is the average depth of ocean water. Okay. And in this zone there is only respiration loss and there is no primary production happening. That is because there is no penetration of sunlight, only respirational loss happens. Okay. You must have to link all these basic concepts that I am explaining with the previous basic concepts that I have explained so that you will get a continuity. Okay. Next is the marine biome. You have photic zone and aphotic zone, and this depth is 1200 meters and this depth is 4000 meters. Okay. This is average photic zone and aphotic zone, and up to this depth only there is availability of sunlight. Beyond that or below that there won't be any availability of sunlight, thus respirational loss will get increased, I mean as it goes below, but then there won't be any production happening. Okay. By production we mean production of food for lives. Next is critical depth. What is critical depth? That 1200 meter distinction that we are making, right? That is called as critical depth. So the depth at which primary production ends or it becomes zero is called as critical depth, and it is the boundary between photic and aphotic zone. So critical depth is the boundary between photic and aphotic zone, and at critical depth decreasing primary production at critical depth, decreasing primary production and increasing respirational loss tend to be in balance. Yes, obviously, right? So there is decrease in primary production from the top. Let us consider this to be mean sea level, and this is 1200 meters. Primary production keeps decreasing, and then even below this point there will be decrease in respirational loss, and even here there is observation of respiration loss, but primary production becomes zero at this point. Primary production is equal to zero at this particular point, that is called as critical depth, and at this critical depth there is a balance between primary production and then respirational loss happening. Okay. Next, based on these lifestyles, vertical habitats are classified as two more, that is pelagic and benthic. Pelagic means off the bottom, which is above the bottom, and then benthic means on the bottom, which is on the bottom. Okay, it can be both photic and aphotic. Pelagic can be photic and aphotic. When you see the picture, pelagic can be found here or here. The only condition here for pelagic organisms is, or pelagic zone is, they are not on the bottom. Okay, which means they are off the bottom, which means they are above the bottom. But benthos means they are on the bottom, which means they are attached to the bottom. Okay, so pelagic is both photic and aphotic, but benthic is always aphotic. Okay, because they are attached to the bottom. Such distinctions you need to understand. Okay, so it will always be aphotic, or aphotic is also called as profundal, right? So yes. Next, all these statements are important from exam point of view. Directly they can be asked. First thing is, over and above critical depth, biodiversity will go on increasing. Yes, it will go on increasing over and above critical depth. Okay, so when we move upward critical depth, this is critical depth. When we move upward, there will be increase in biodiversity. Yes. Next is, when moving from mean sea level to critical depth, biodiversity decreases with increase in depth. The opposite. Okay, so mean sea level is here. Okay, so when we move from here to here, then biodiversity decreases. Next is below critical depth, biodiversity will go on decreasing with increasing depth. Yes. Okay, when we go below critical depth, there will be decrease in biodiversity. Next, thus in aquatic ecosystem, so all this is depth dependent, right? So aquatic ecosystem production is depth dependent, but respirational loss is independent of depth, which means respirational loss continuously decreases when we go below, but production up to this point only. Below that there won't be any production happening. Okay, so such distinctions you must have to understand very clearly. Next is biodiversity will be higher in photic zone in comparison to aphotic zone. Obviously, even in aphotic zone there will be biodiversity, but then biodiversity will be considerably lesser. That is because primary production will be happening here. Here there won't be primary production, there will only be respirational loss. So biodiversity in this region will be very higher when compared to this region. Okay, so these are the important points which you